Okay, this will just be a really quick video on understanding limiting and excess reagents. Now, to really understand that, you have to have a good grasp of stoichiometry. And as always, I'll start with a visual example first. In here we have 6 hydrogen molecules, which is represented by the white diatomic molecules, and 4 chlorine molecules, 4 chlorine gas molecules. So 1, 2, 3, 4. Okay. And after they react, each chlorine atom pairs up with a hydrogen atom. So you get HCl, right? That's what we get. We have 8 HCl's. We have 1 HCl, 2 HCl, 3, 4, 5, 6, 7, 8. But if you look here, for every 6 hydrogen molecules, we need 6 chlorine molecules. We don't have that. We only have 4 chlorine molecules. So what ends up happening is we only end up producing 8 hydrochloric atoms, and we have 2 hydrogen molecules left over, which you see over here, right? And if you count the green balls, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, conservation of mass, it's still the same. And same with hydrogen. If you counted it, you would find 12 white balls here and 12 white balls over here. But not every white ball is paired up with a green ball. 4 white balls are left over because they don't have enough chlorines to bond to. And that's limiting and excess reagents. In the reagent section, we have the chlorine is the limiting reagent because it's limiting how much HCl we have. If we had 1 more chlorine atom, then we could produce 2 more HCl. We could produce 10 HCl, but we don't. We only have 4 chlorine. My bad, I said atoms. We only have 4 chlorine molecules. And what's in excess is hydrogen. Okay, the hydrogen is in excess because we have more than enough. We have too many left over. So that's limiting in excess. We can, how does this apply to stoichiometry? What if I had 2 moles of iron oxide and 2 moles of carbon? What's the limiting and what's the excess? Well, think about it. For every 2 moles of iron oxide, I need 3 moles of carbon. If I have 2 moles of iron oxide, I need 3 moles of carbon, but I only have 2 moles. So this is limiting. And what's in excess? That's iron oxide. Iron oxide is in excess. Okay? Another example, what if I had 1 mole of iron oxide and 3 moles of carbon? Well, if I had, 1 mole of iron oxide, I only need 1.5 moles of carbon, but I have 3 moles. So 3 moles, that's more than enough. It's in excess. And iron oxide is limiting. Okay? And once again, we use our good buddy mole ratio to figure out, let's say this was 1.73, and this was 2.56. We want to know what's limiting and what's in excess. Well, let's do it. We have iron oxide over carbon. The mole ratio is 2/3, and we have 1.73 iron oxide, okay? And we replace with X. We don't care about one of the reactants. Okay, we scratch that and we just replace it with X, and we solve for X. When we solve for X, we get 1.73 divided by 2 times 3. We get 2.595. Okay? Now this is how much carbon we're supposed to have if we have 1.73 iron oxides, and we do. But we don't have that much. We only have 2.56. So we know this is limiting and this is excess. So that is an introduction to limiting and excess reagents.